Go. Hello. Hello, Mr. Miss Alright, right? Yeah. Okay, so look, if we play n games, yeah, we have played n games.
End game.
Yeah, n games. And for each one, you can. There are only two kinds of outcome. You either win or you lose, right? So you either win or lose. You win or lose, right? So how many ways that in which that you can have this consecutive k wins or less, but it has to be consecutive. What's consecutive?
Order.
Okay,
Like
consecutive.
1, 2, 3.
Consecutive.
1, 2, 3.
What-
6, 7, 8.
What's consecutive?
In order.
It's continuous. So you win, like you win the first game, second game, third game. That's consecutive. But if you win first game, you lose the second game, you win the third game. This is not consecutive. Okay. So we are looking for we're looking for the number of ways that you can win k times consecutive or less, right? So for example, there are three. When n equals 3 and then k equals 2. So we play 3 games, and then look, we can win. If we play 3 games, how many kind of different situation will that be? I mean, what's the permutation, total number of permutation? You should be able to answer this question quickly. We play 3 games. Each one has 2 possibilities. How many possibilities altogether? 8. Yeah, exactly. 2 to the power of n equals 8. Okay, at this time. Okay, so look, if I write this L, R. Yeah, so you should be able to write L. What's R? Okay, so actually it's win. Okay, win. Okay, and okay, so this. Oh, I write the R again. Why I'm keep writing on this R again? Okay. How many? 1, 2, 3, 4, 5, 6, 7, 8. Okay.
9.
Yeah. So lose 3 times in a row.
Isn't that
K equals 2. Yeah, I know. So these are all possibilities. A of possibilities. How many of them have this K? Less than 2 consecutive.
that one doesn't?
This one doesn't. This one, yes. Right? Yeah? So that's 7, okay? So you give me the 7, right? Yeah?
Yeah.
So what's the source? I mean, what are we doing here? What's this approach? If we iterate, if we list all the possibilities, what's this method called? Brute forcing. Yeah, exactly, brute forcing. Look, because it's very slow. Why? Yeah, because look, if n is big.
Possibility.
Yeah. And we have to do this 2 to the power of n times. This is just to iterate, to list all the possibilities of all the games, and we have to find out how many of them are consecutive. Yeah. So this is the time complexity. If we're given a game outcome, and it takes O(n) time to check if they are less than k, if it meets the requirement. So the time complexity is O(n) times 2 to the power of n. Right? This is total complexity. Okay? Do you get it? Yeah. So certainly we don't want this. Right? This is too complicated. Right? Too complicated.
Weirdo.
Yeah. Okay. So how about if I can tell you that if let's say we define a function fi, j. What does it mean? Okay, listen carefully. Okay. It means that we are playing an ice game, and then we have now j wins, consecutive wins. Okay, consecutive wins. Bowling game, yeah. Okay, consecutive wins. Okay. So look. So let's say, look, I have played the ice game. Okay, so I have lose, win.
But
Okay.
I said that you only can do 3.
Yeah, I know, but this is example, but as an input. Okay, so let's say, look. Okay, so there are I, yeah. There are I here. So this is I. There are eyes. Okay, eyes. And then we have J wins, J consecutive wins, okay? Yeah. So, okay, so I'm playing the I+1 game here. Okay, this is I+1 game here. How many possibilities for this game?
Times.
How many possibilities? I'm playing I+1 game. What's the outcome of this game? How many? Come on. Ryan, how many? What's if I'm playing this game, ice game, how many possibilities?
7.
For this game, I'm
Two.
2, yeah. Win or lose, exactly. If I win or lose. Lose or win, yeah? Right? So if I lose, so I'm playing I+1 game. But if I lose, what happens to this consecutive win?
0.
0. Okay, but if I win,
J plus 1.
yeah, I+1, J +1. Exactly, yeah. That's very good, yeah. So the outcome will be, so look, Fi J will be equal to these two added together. Exactly, right? And when we reach the end, means that we have finished all the games, right? Yeah.
Yeah.
Then we should check if J is less than or equal than K, right?
Yeah.
Okay. Okay. So, but when K, look, when the J is bigger than K, we return 0, right? Because we don't want the consecutive wins more than K, right? This is the requirement, right? Yeah. So, but with this we should be able to implement this using recursion, right? Easy. Okay. Let's write this in recursion. Wow. Define Fij. If J is bigger than K, return what? Return 0 or 1? Come on. 0, yes.
0.
If I equal n, we have play n game, return 0, 1.
1.
Yeah. Otherwise, return what? Return what? It's on the ball. Come on, return what?
Return F plus I 0 plus Fi plus 1 J.
Yeah, this is the recurrent formula, right? So I plus 1, J plus 1. What's the time complexity for this one? What's the time complexity? Actually, what are we doing here? What's the time complexity? It's the same as brute force, right? Something like that, right? Because each one you have 2 possibilities. Each one you have 2, so 2 to the power of n, right? But how do we make it faster? What's the missing thing here?
Cache.
Cache. Yeah. So what do you mean? What happened if we put a cache? What happened? What happened if we put a cache?
Is an explanation of.
Yeah. Why is that? Because we're memorizing it, right? So look, I has n, right? I is from 0 to n to n minus 1. So there are n states of the I, and there are k states for the j. So the time complexity is what? How many states of these? How many states, right? How many? Look at that. No. How many states? There are n possibilities here. K possibility. How many total states?
N times K.
N times K. Okay. And the time complexity and space complexity is also n times K. Why is that? Because there are at most n times K states. We need to memorize. Yeah, memorize.
Memorization.
Okay, so what does it mean? Look at look. So we can do a tree here. We can do a tree. Okay. Look. So for example, at the beginning we put F0, 0, and then we need to go from F1, 0, and then it needs to F1, 1, right? Look, F1, 0, again you go to F2, 0, and then plus what? F2, 2, right? You see?
Yeah.
So F1 will go to F2, 0, and F2, what? F2, 2 again, right? Is it F2, 2? No, F2, 1. Look, F2, 0, F2, 1 here. So what's the problem here? If I'm just iterating a few iterations. The problem is what? Look at here. This one, F20,
Yeah.
and here F20 as well, right? So
Calculated twice.
twice. So the first time I calculated, I memorize it, right? So when I calculate this one, I don't have to expand the tree here, right?
Yeah.
For example, you take 1 day, you spend 1 day in this tree, right? You spend 1 day finding out the F21 value. But here, you want to calculate F21, F20 here.
Yeah.
Do you need to spend another 1 day to? Why is that?
Because he remembered it.
Yeah. Yeah, exactly. So I put it down. I put it down on the notebook, hash table, hash. Right? It's the same thing. You work out a very complicated mathematical problem, right? You put it down on your notebook. The next day, you find out, okay, it's the same question. Do you still have to go through this?
No.
You just look it up, right? You just tell daddy, okay, I know it. Quick, one constant, right? So that's how we speed up using this cache, okay? This is quite similar to Fibonacci number, remember? What's Fibonacci number? What's Fibonacci number? 1, 1, 2, what's the next Fibonacci number?
3, 5, 8,
13, etc. Yeah, exactly. Fi equals
21,
Fi
34.
plus Fi plus look. So the first two numbers equals the added together will be the next number. Yeah. So this number is Fn equals Fn minus 1 plus Fn minus 2. Yeah, it's quite similar to this. Yeah. So you expand this Fibonacci tree, you'll find lots of these F values are repeated. So we have to cache it, right? That's the magic of caching. Here, okay? So here it's the same, yeah? For each game, this is top-down dynamic programming using recursion, using the keywords minimization. So at this game, we know we have already played ice game, yeah? And then we have J consecutive win. And so if we play the next game, we have two possibilities. Either win, continue the streak. Yeah, streak. What does this mean? Streak. Yeah. We continue. We win. We keep the streak. Or we lose. We reset it to 0. Right? Easy. Right?
Mm-hmm.
Yeah. And then we finish the game. When I equals n, we return 1. Yeah. Because at this point, J. Why we can return 1 here? Because at this point, J is smaller or equal K. Why is that? Because if J is bigger than K, we already return 0. Okay? Yeah. That'll be it for today. Good job. Bye bye.
Bye.
Bye bye.